this video, we're going to use resolving forces and the fact that resultant force is 0 when a particle is stationary. So it's told us that there's a child at a point P and there's a cable sort of holding that child in position, and also that cable is elevated at 2 degrees above the horizontal, meaning this angle here, pretty small angle of 2 degrees. Same on this side of things, by the way. This angle here would be 2 degrees. I'm just going to write that out just because I'm going to draw that clearer later. It says add labeled arrows to show all the forces acting on the cable at point P. Well, on the cable only, there's tension acting, and that applies whether it's a cable sort of connected to a person, whether it's a toll bar connecting two cars. Whenever two objects are connected, that object that's connecting them has tension going up it. Let's now use that to do part 2 of the question. By the way, acting downwards would be the weight of the person themselves, which we're going to take into account in part 2. So it says the total mass of the child is 40 kg and show that the tension in each cable is 6,000 newtons. Now it's told you that the person is in position and stationary. That means that resultant force is 0 in the vertical direction and horizontal direction. We're going to use that in the vertical direction, and I'll show you why. So if we start by labeling P, there's a weight of W going downwards. You have to be careful with components here, because if we look at only this section here, and let's draw our own right angle triangle out. Going up the rope is tension. We know this angle here is 2 degrees from the horizontal. What we want is the vertical component of this tension. How do we find that? Well, we use SOHCAHTOA. So let's do that in a different color pen now. Using this angle here, this would be our opposite, and this would be our hypotenuse. So we're going to use sine to find the vertical component. We say sine of the angle 2 degrees is equal to the opposite, which we're trying to find, divided by the hypotenuse, which is the tension. Multiply both sides by t, and we get that the opposite is t sine 2. So the vertical component of this tension is t sine 2. This exact same process applies here, so I'm not going to do that. But in total, weighing upwards is t sine 2 plus t sine 2, so that's 2t sine 2. Since we mentioned resultant force is 0, that means that the weight, which is mg, which is 40 times acceleration due to gravity, which is 9.81. You can use 9.8, by the way, just in A-level physics, try to use 9.81. And that's equal to 2 multiplied by the tension that we're trying to find, multiplied by sine of 2 degrees. From here, you just rearrange to get tension. So you divide both sides by 2 sine 2. We get tension is 40 times 9.81 divided by 2 sine 2 degrees. That should get you something that rounds to 6,000. I'm just going to double check that for you. 40 times 9.81 divided by 2 sine 2 equals... Oh, remember to close your bracket at the end of the sign. 5,600, which does round to 6,000 to one significant figure. A little far though, but still the right answer. Hopefully that all makes sense, and if you have any questions with it, just let me know in the comments. Otherwise, be sure to like the video if it helped, and be sure to subscribe. I'll post more content like this very soon.